Hello? Hello, hello. I have no idea how to test if I'm actually live. It says live. Should be helpful. Okay, 1 second. Hello? Hello? It says live. Okay, good enough. Hello everybody. Today we are going to be doing the MAT. The reason that we're doing the MAT is because I'm actually taking TMUA this October, I think. And we can't be taking the TMUA without preparation. But the TMUA only has 7 past papers, so we are doing, some more MED actually. Okay, last time I think I did 2022, was it? Now we're doing 2014, so we'll be kind of randomly picking some papers, maybe doing a multiple at once because some of the early ones, particularly 2007, was really easy. So just for the benefit of having some kind of entertainment, we might do multiple kind of events. So yeah, with that said, let's start now. So you'll notice that we are only doing section A, because section A is the multiple choice question part, and section B whatsoever, those are long questions which I have no idea. So we're just gonna go, okay? And in free. Just a side note, I've actually done the MAT or PMUA practice in 3 months. No, 6 months. So yeah, I'll probably go for this one. I mean, hey, I'll be happy with, I'd say I'll be happy with a 7 out of 10, maybe 6 out of 10. But I don't want okay, so in 3, 2, 1, let's go. Okay, so first question. Yes, oh god, what's happening now? Okay, so the first question is inequality is satisfied precisely when these, or she, so yes, that works. So A, fuck, so B, what the hell? Okay, so A is, so we can shift all of the bits of the inequality over here. Uh, x squared is u, so u a x. We can solve this. How do we solve this? Okay, so it's probably gonna be. Ah, wait, whoa, no, I'm dumb. Right. Does crossing out work? No, it does not. Okay. So, okay, let me just pause this because I need to adjust my settings somehow. I need to make it so I can kind of erase my answers. That would be useful. So does this work? Okay, let's see. Does this work? Okay, there we go. Okay, so now you can see we've got razors up. Okay, so second point, right? I know how to do cross method. So cross method is just plus one. So it's u plus one, u is two. Um, yes. So um, x squared equals -1. Is it? Yeah. So x squared equals -1, which is non-solution, or x squared equals 9, and 9 means -3 or 3, so we can probably conclude this A. Okay, this is question 1. That was just a simple quadratic inequality. The graph of the function b, this is sketched in, okay, so we've got a log function, and then we have some various curiosities with it. Okay, wait, a log 10 graphs looks like this, right? How it is achieving that? Very interesting. Okay, so, God, I really have no idea how to approach this. Okay, let's see. Let's sub in 0. That's always a good thought. Okay, 0. So just log 10 2, which means we can probably scratch. It's not D. It's not C. So there aren't really any values that would give me some kind of clue to this. We could scratch out D if it's up in 4. Yeah, let's do that. Okay, so D, let's see, so it's 16, A, 2, and then that's just 10, so we should expect it to be around 1. So it's either A or E. Okay, wait, I completely forgot how logarithms work. Okay, so when is it equals to 0 again? So let's say A, so that means that y equals A, so when A is 1, okay, so when is this equals to, so that's just this, negative, so, okay, so this is squared, x equals 1, so when x equals 1, it should have negative 1, so that means it's E, okay. So yeah, by using how log works, we can figure out that there is a minimum point at 1, so that means it's E. Okay, so next up, let's go to C. The cubic, funnily enough, has a turning point. It has a minimum when x equals 1, precisely for this. Okay, so my first thought is differentiate. So let's go free k squared. Let's do the standard differentiation stuff. And we need it to be a minimum, so oh crap. Yeah. Okay, so we need it to be a minimum. Let's just go like this. So now it's looking something like this. Okay. And that has to be bigger than 0. This has to be equal to 0. Okay, so let's first sub in the second derivative. So x equals 1. So it's looking something like this. So k has to be bigger than 1 over 2. And then let's examine the first one, which has to be equal to 0, because otherwise it's not a thing. Now there are only inequalities in the provided options, so these cancel out, these cancel out. So it's always equals to 0 when, yeah, so it's always equals to 0. Okay, fine. Then the answer is just C. Sure. So that was just very simple differentiation. The reflection of the point in the line has coordinates. Yes, it does. That is correct. Oh god, what the hell? Okay, so let's draw graphs. So we know that the intersection point is here. So one of them looks like this, one of them looks like this, one of them looks like this, etc., etc. Oh wait, it can also be negative. So let's draw some negatives. Okay, so here, and then the reflection of the point is x. Here, yeah. So it's just oh crap, it's just here, right? because it's x equals 1, y equals 0. So, how is that reflected? Hmm. I have forgotten how reflection works. Okay, it's not a topic that comes up very often in GCSE or A level, how to like analytically do it. So, um, hmm, the reflection of the point has coordinates. Can we immediately dismiss some of these answers? We probably can. For example, it's not B. That's well obvious. Actually, yeah, let's just sub in random values until we get one. Okay, so for example, it's immediate. Oh fuck! It's immediately obvious that. Oh fuck off! It's immediately obvious, right? That if if m equals -1, so go like this, then it's here, right? So that is where the point would be reflected. So let's see. So wait, what would the x and y be? It'd be y 0, 1, right? So that's a point. That's a point. So let's see. For a, it would be 2 divided by -1. Wait, negative. Okay, m squared should be 2 minus 0. Oh, so that's wrong. So for d, yeah, c is wrong. It's negative, my bad. C is wrong. D looks wrong. Is it? Yeah, so 1 minus 1, so 0. Oh, wait, no, this has potential. Yeah, so that doesn't matter. 2m. 2m. Because B is correct. And then what's E? E is M. So D and E are both correct. Oof, so it's one of these. Let's see. Well, I'm running out of like trivial answer. Say M was like some really big value like this. Some arbitrarily big value. M was really big. Then it'd probably be reflected over here. That's not reflected in E. So we're gonna guess educational an informed guess that it is probably D. Although I wouldn't be surprised if it was wrong. As x varies over the real numbers, large value taken by the function 4 sine squared x plus this number equals fuck. Okay, well this is just a simple sub. Let's see. So this becomes 4 minus cos squared plus cos equals 1. So cos, if cos is equals to 1, no. What the hell? How do we maximize this again? Okay, right. I haven't done enough practice of these in the past, like, month again, so it's a bit fried. Give it some time. Let's be squared. How do we... We're not trying to find 0, we're trying to find the maximum value. Look, I know Dead Air is bad for streaming and for, like, Oxford questions, but it's fucking 40 degrees and where I'm living, it's not 40 degrees. It's like 30 degrees and unusually humid. So my brain's fried. I don't know what the hell the answer is. Let's see. So I could make an educated guess again and say that it's probably this. And this does seem very correct. See if that's the case. So it becomes this. Fuck. Yeah, okay. That seems correct. So it becomes something like just -4 plus 2 plus this squared, which is 3/2, some mess like that. So it's 9 plus this plus 8, 17. Oh, no. Oh, yes. Ooh, it is an answer. A. Okay, fuck it. A it is. I don't care. It's probably wrong. My brain's fried. I don't care. Let's go. F is a real number defined by this mess. Applied s times, and it's applied t times. Functions. That is this. You can do some things using that. Yeah. So, app. Okay, gotta remember to keep talking. This practice for an Oxford generator, right? Okay, so functions s and t are defined by real numbers as adding one and making a negative. So we know bare minimum that if you apply t once and then s 8 times, then you could most likely get, so it'd be something like this, which does equal f. So 8 is a minimum true. However, is this the only case? Let's think about it. Because It is entirely possible that, for example, you add a couple times, that becomes a sort of 2, you t it, the entire thing becomes negative, and then you add times 5. Okay, so you s times 10, right? And then that becomes negative 8. So then we can determine that t must be odd. S indeed must be even, so it's C. That was surprisingly easy. Okay, so because t has to be odd in order to make x negative, and then s has to be even so that it can give us 8. Yeah, that makes sense. And since any negative number added must be cancelled out by positive number, so yeah. Okay, so let n be a positive integer. There is a coefficient. You have to mess with it. Okay, so this is an example of a trinomial expansion. So if we take something like this, and then we have x squared. Okay, so it is x cubed plus y to the power 5. So let's just draw some of these out. Should be right. So let's see. 0n plus 1 plus 1 equals n x cubed. This, and then so on and so forth. Let's get to the ones where it starts mattering, right? Because it's this plus, let's say, this. Is there a limit, like a solid limit, to where it stops mattering? Because, okay, let's see. It has to be x squared plus x squared. Okay, it has to hit x cubed twice and then hit this. Is there a limit to the trinomial expansion where it stops mattering? We have 1, 2, 3, 4 plus 4 questions left. So if there's a point where it stops hitting, yeah, we know this. In fact, we know that the point it stops hitting is 4, because it has to hit 4 times. Okay, so the only one that matters is this one. All the others are irrelevant to us. Okay, so then we can. Oh, wait, this is easy. So then it's just 1, 4. It says my notation. I just fucking realized. It's not, isn't it? It's the other way around. Oh, fuck's sake. Right. So we reverse the n and the 4 like fucking morons. Right. So it's actually 4, 1. Right? And then x squared is 3, y. Okay, no, this is irrelevant. Like, this happens still. And then, actually, so it's like this. X equals 1. It's a bit odd. Okay, so it's actually 4 and 4, which is d. That's the value that we're getting. Because it has to hit 4 times. And we're summing up them all. Right, so pop, 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 pop. Okay, sure, fine. That's the answer we have now. Probably wrong, whatever. It's defined as a function, lovely positive integer. The base case is 0 when it's 1, and for n plus larger than 2 or equal to 2, it's that. Oof. So it's recursive of some division. Really? Alright, so we do the classic thing, which is rods and paces, so 2 divided n. This becomes 2 for 3. It becomes 5. Oh, so it's basically like a weird, like, summing thing. Okay, so it's not because it's okay. It's not that hard. Sure. Okay. Okay. So we know that multiples of 6. There's 1,000 of them between 1,000 of them, right? It's times 4 plus how many multiples of 2 which aren't also multiples of. Okay, so 2 out of 3 times 3,000? Is it? Yeah, 3,000. So actually, that's 200,000 plus 2. So that's multiples of 2. And then. Mm, and now it's have multiples of 3. So that is 2,000 and half of those. Yeah, okay, so half of those. So something like that. And I have a feeling that this is wrong. So it's 4 plus 4 plus 3, so that's 11. But 11,000 is a really clean number, which I don't like. Is there some kind of trick I'm missing out on? I don't think there is. I think it's genuinely just 11,000. Like, I don't know. Okay, so the graph. Oh, this is the one. Okay, so when I was making a thumbnail for this video, I spotted this. I spotted it was terrible, and first I declined to create my thumbnail with it. So the graph is this, and it can be obtained through some descriptions of stretching and doing this and that. So my first part would be, can we complete the square with this, right? Because if we can, that'd be pretty big. Am I completing the square correctly is the question. I think I am. Oh, shit. Okay, so yeah. So that's what we've got. So now we've got to do a number of changes to it. So what I'm thinking is actually, what is the stretch? The y-axis, right? So stretch y, because of this, and that's stretching it like in the y-axis. Because think about it, right? This is the turning point, so we know that they're all being stretched and translated and whatnot. There are no reflections, I don't think, because nothing in here is negative. So this then is on the y-axis, a translation. Yes, y translate. So that's wrong. Is that an order? Is that a question of order? So parallel to the x-axis is like that. OBS is disconnected. That's not good, is it? Oh, sure, it's reconnected now. Okay, that's odd. This is an odd question. What the fuck? Hey, I knew this was gonna be bad. Okay, so is this a stretch or is this a translation? Oh, it's a translation, I think. So now, okay, so what you're doing is, right, you're taking this, which is y equals x squared, and then you're making it so that the turning point is actually 2, -1. So it's actually somewhere like here. So now this is the new thing. Now, in order to do that, you can't be reflecting, so E is right out. But then also it's over 2. That shouldn't matter, should it? Yeah, it shouldn't matter. Uh, BD, I just do a copy reflection, you know. You're moving it about, but do a copy reflection. So that's A, B, or C. You know, they all have some kind of stretching in it. So the assumption that there is no stretch is already wrong. So let's stick with what we know, which is 100%. This is a Y translation, right? Wait, yeah, like this is a Y translation, right? We maybe try and graph the original function. Okay, so it's 2x, which looks like this. No, it doesn't. That's a log graph. So it looks like, it looks like this. And the x squared looks like this. Shit. So then the x squared looks like this. That's just a simple. So actually, this graph is an even function, right? Because it's the same on both sides. Because it's squared. Actually, it should be looking like something diabolical like this. Then what's the 0 point of that? So that's just, so it's x squared or x minus, so it's x over 1. So at these 2 points, that equals 0. This is the original, so this is squared. Shit, no. So this is 2 square x. That's the graph. And then at x equals 3 or x equals 1, y is equals to 1. Can't really go any lower beyond that. Good, good. So we could approach that a tiny little bit. Yeah. So it looks something like this, maybe, but never really touch 0. So yeah, this is 1, this is 3. A, B, or C. Say C is also wrong. Because I think there are 2 translations on 2 separate axes. Like there are 2 transformations, they're on different axes. So actually, that also rules out A. So I'm just saying it's B, though I'm really not sure. So finally, let's look at J, which I saw this while I was making the thumbnail. This is easy, okay? This is integration. So what we're doing is we're integrating, like you do, and we're integrating by this, right? Sure, whatever. We're integrating by this. Okay. So, we're doing it. We're integrating. So it's not that bad, I think. If I remember, like, most of my techniques correctly, it shouldn't be that bad. So then, okay, so let's assume that this entire mess equals some fucking I. Assume equals K. Okay, so we've got K. We've got this being integrated. Since K is a constant, so we can just pull it right out. At least I think that should be how it goes. So now we've got this. And now you got this, right? That's more of K. You got this mess, which should integrate something like this. So yeah, you got something like this here. Then you got this. Which is like the one part that I don't remember. Okay, so let's think about it this way, right? So let's say we got this ugly ass function feeding in like 1 and 1. Okay. Okay, there is some trick to manipulate this f of negative x into f of x, but I just can't remember what's the trick again. Okay, so it's this. right, is probably equals to this. Like in theory, it's right, right? Because this is also equals to this. I think. Right, man, let's just assume it's that. Yeah, we'll just refresh this after, because I have no idea. Sure. So now we've got some values. Yeah, we plug in. So this is 12. And that's just 2. Okay. Is equals to negative 12. Fuck. Okay. Shit, that's not a good answer, is it? Because we don't have that as one of the options, which isn't very good. Ta da 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 da. Boiling. Okay, right. So, we've done something horrifically wrong. It can be established, but we've integrated both sides. Honestly, that'd be looking fine. So I ain't too worried about the fact that we've integrated both sides. I'm examining all of our workings. So this is definitely correct. This is definitely correct. This is a bit sketch. I ain't too sure about that. But it does look correct. It does look correct. This, though, now this is a fucking mess. I don't know how to think about that. See, if we turn this positive, I mean, we turn this negative, that turns this into 12. That turns this into 4. That turns this into 8. That's the right answer now, because I'm just going to assume that I did this completely wrong. So I'm just going to assume all of this is wrong, right? Okay, so we have bullshitted answers to most of these questions. Let's go back to the start and just kind of examine these. Right. Handwriting was so perfect at the start. Right. So boiling. So we use up. We do some. We get two answers, which look kind of correct. So four. Let's assume that's right. And then we do some weird fuckery with that here. So we cross out options. Um, cross out the 7 2. Cross out B. Sub 4. Okay, so x equals 4. Then we sub that. And then we sub that. Okay, that looks good. And then the cubic of the turning point has a minimum when x equals 1 precisely for k larger than 0. B, a bunch of numbers. It's larger. Okay, so k, free k, x cubed. Just integrate. We've differentiated that. I'm just so hot. I had to close the windows and the doors so that none of the noise pollution from this pollutes out. But oh god. I have water here. I have to drink that also shouldn't. Right. So then, God, this looks right. Okay. This right. So through a number of guesses that I'm not going to be able to verify in a minute. Right. Let's find something we can verify. Not this. Right. Let's go. Okay. Are any of these like not guesswork? Which I can. Yes, this wasn't guesswork. So S&T are powers of two. Oh no, clearly not. Clearly not. What the fuck? No. No. Oh. Alright. Wait, what? Fuck. Did I verify? Okay. He can be even. And yeah, okay, so A is a thing, but the other one encompasses it too. So this one is coefficient. You know what? I'm just gonna pause the timer 30 seconds ahead. I don't give a damn. I'm so tired right now. Okay, so that is it. We have concluded this awful, awful, awful experience. Let's see if the stream health is good. It's not. No one showed up, which is expected. Let's see views. Yeah. Okay, so let's see here. So 2014, as you can see, completely blue. ING. Let's see here. So yes, let's be yes, yes, yes. Somehow, fuck. Yes, yes, yes. Again, somehow. Yes, yes. Okay, so we got a question wrong. Oh no. We suck. Alright. So his was literally just the guesswork one, which we transformed into this. Oh, you can complete the square with this. Oh, that's an A. Because I assume that it was cost 45. I thought it was a third. It was not a third. Ah, so that's an A. Okay, well, I mean, cool, I guess. Yeah, fair enough. Got that wrong. Here's 7.5. Oopsie daisy. Oh, alright then. Okay, well, that concludes our adventure. Next time I remember to complete the square. I'm so goddamn fried right now. It's so hot. Oh my guys. It's so hot. I didn't even know it was possible for temperatures in Britain to be this high. It's miserable. How they made it this hot? Also, this paper was surprisingly easy. I know I was complaining the entire time throughout it. I was burning. Oh, I was dead. But at the same time, this really didn't feel like that hard. Okay, this didn't feel that hard. So that, that concludes. Right, a lot of these were guesswork, but it was educated guesswork. And if I can guess, enough of my questions on the TMUA, then I suppose I'll be doing all right. So, according to my schedule, we're going to be doing one MAT paper every day, one MAT, and then at the end of all of the MAT papers, then I'll do one TMU paper, which I can't remember. I've designated it already. I just can't remember which one. I think it's one of the more recent ones, so maybe 2022, 2023. I really want to get a baseline for how well I'm going to do in the actual thing before I do any revision. Now, astute viewers will be able to spot that I did do a paper. That was the specimen paper, which doesn't really count because it was a lot easier than the other paper I did, which I'm not going to review. Actually, I can review. Come on. It was not here. Okay, I did it on my other account. So yeah, okay. I suppose we could also take time on the stream in order to look at the answers and just kind of adjudicate myself. Okay. So the first one, we can rewrite the inequality as a number. We can then do some numbers with it. Yeah. Okay, well, this is pretty easy. I'm just going to skip. Right. So, B, we can complete the square. Oh, fuck, you can do it analytically. Okay. So I crossed out solutions manually. That took me a couple of minutes. Let's see what we did here. We can complete the square and the quadratic to get this number. Let's see. Shit, where's the paper gone? K. So, let's see. The graph of the function is log 10. So, we'll complete the square. Substitute x1. Oh, so they pegged it before me that you can just find the minimum points. Because that's the only thing that's unique to each of these graphs. There's no minimum point here. There is a minimum point at -2 and 0, 0 and 2, 1, a -1, and 1. So that's the unique thing across all of these graphs. So that's how you solve it in like 10 seconds. Ah, okay, ingenious. So derive, which we found fairly easily. Oh, this was the one that we didn't really get. This was the one I had to basically cross out individual solutions for. So D, one might note that D is the only vector that has a unit vector for all values of M. What the fuck? I like the answer that takes one line of explaining as opposed to the huge amount of. So let's examine this. So one might note that D is the only vector that has a unit vector for all values of M. What do you mean? Oh, ew, ew. Okay, so let's see. A can be crossed out fairly quickly because you can divide by 0, and that's not really one of the things that you want to be doing. B is also immediately obviously wrong. What does unit vector mean in this context? As a reflection is distance percent. I'm going to turn on my fan. Right. Other streamers have YouTube, music, Spotify, playing the lo-fi hip hop. We have a fan. A fan provides wonderful entertainment. I appreciate I haven't been all that entertaining in this. It's mostly because I've been dying because of the heat. But yeah, I appreciate this is the most entertaining. Maybe I should go and edit this. Perhaps that would be a wise idea. But also that requires I have to listen to the entire thing. So I don't know. Perhaps. We'll see. So the first derivative is given by these numbers. One might note that these only vector as unit vector for all values of M. What does this mean? Reflection is distance preserving. Maybe we Google unit vector, right? Maybe that will provide me some insights. Unit vector. It's exactly one. Okay, well, how does this help? Give me a sec. Well, wait, you see that the magnitude for this is always one. That's it. Not magic. Don't just look at it and say, "Oh, that's a solution." That's not how it works. Genuinely, how have you achieved this? What? What? Okay, no. So, let's see. So we square root this entire thing, right? Square. Does that work? That does work. Okay, so then it's this 2m squared. Squared. Okay, this. Squared. Okay. Does this work? Then I feel work. So then you square root that. This. And this becomes 4 squared. 2 squared. What's 4? Shit. What are you doing that again? Right. No, piss off. Right. Piss off. Okay, right. Oh, I don't believe you. What the fuck? So this becomes this. This is then m4. That is then 2m squared. That's the 1. Right? That's the magnitude. What you say is always 1. By the way, that's what you're saying. This is always 1. I feel like this can be differentiated. And then this. Oh, so this is 1. Okay, so that's how you differentiate. You take the magnitude. Okay. Oh, oh, that's well weird. Oh, I mean, yeah, but that's the greatest reach I've ever seen. Okay, no, I don't believe you. Okay, so now we can prove that yes, this is a unit vector. Sure. How does that mean that? How does that mean that this is the only correct answer? Because let's think about it. Because it's here. Is a reflection distance preserving? That's a thing. That's a thing. Oh, is that like some kind of axiom? Like if the line always crosses through here, then like it would be reflected like here, for example. And that's a no, because that m is equals to 1. So that's like that could be a special exception, right? Okay, that's right. Okay, so what the claim here by the good example is that. Wait a second, let me just pull up my pen again. Pull up my pen again. There you go. Okay, there we go. So a claim by the good example is that for this line, okay. So let's say we draw something like this, and then this is somehow distance preserving. So the distance from here to here, right? And then you select this, so you put it like somewhere here, let's say, and this, right? Distance between the point and the origin is the same. The same. Why? What? Where is the proof for this? Sir, sir, where's the proof? Proof. With the give me the proof. Be the only answer that I agree with this. Or one I calculate the image using geometry. The line. No, but no, but you can not all reflections are distance preserving. Like this isn't the distance preserving. No, it's distance preserving relative to this point. That's the like okay, so it's distance preserving relative to the perpendicular bisector of the line which crosses through both points. That's how you figure it. Oh, okay. That's really weird. Why would you ever think of that? What the hell? Yeah, but like, bruh? Okay, sure. Okay, so a reflection is distance preserving on that specific point. Okay, sure. I'll remember that in the future. If that ever comes out in the TMUA, I'll fucking rip my heart out. Right. Alternatively, we might consider the case when D becomes large. Okay, so that's what I did. Okay, I'm not looking at the third answer. I already have two possible solutions. So sure, whatever. But that really pisses me off. That's not something that you would like naturally figure out. And then E is where you complete the square. So this is just complete the square. So yeah. Remember. You can just sub like x, like u into like quadratics and perform all operations. Operation, yeah, sure. Okay. Because like I think I'm more familiar with things like the discriminant, for example. Like the discriminant I will usually spot, but completing the square is it feels unnatural to me. I don't know. It's like I had this weird gap when I transitioned from Chinese to kind of like British education, where completing the square just never really got covered 100%. So I don't like it as a technique that much compared to the other stuff. Let's see. F. So we So you use a weird acronym. Okay, I did this question very quick, but I'm going to say it's not a problem. Yeah. So this is again pretty easy. We found a solution. Pretty easy. We found a solution. I feel like these are all fairly straightforward. We could have, found solutions. Fine, that was a fuck up on J. Because J, I just, I forgot this and I spent a while fucking it up. But yeah, that something to keep in mind for later, I guess. It's not that important. So B, I guess B somehow. Oh, you can take the one out. The one's a constant. That's ingenious. Oh, so that's ne. Oh, okay. So what I did was for most of these questions, I did a lot of like observing and then logically puzzling out which one's the incorrect answer, which will work on the TMUA, by the way. That's 100%. It will work because what you do on the TMUA is essentially the same thing. You get multiple choice questions and whatnot. But some of these are pretty ingenious. Like, I'm not gonna lie. I probably would not have gotten, for example, I or J if it was a multiple choice. I probably wouldn't have gotten uh, a D either, right? I mean, D is the expectation is that you use multiple choice, so I don't think it's that bad. But okay, fine, yeah. So this was an interesting paper, 100%. Next up, we're going to be doing 2020 because that's the actually difficult one. Now here you can see the brilliant thumbnail that I dreamt up. So yeah, we're going to give it a go tomorrow. I don't know what else to say. This was fun. See you tomorrow.